we're taking a look at the differences in boiling points here between the compound magnesium oxide, which is made up of magnesium and oxygen, and magnesium, which is just an element, magnesium. And so the difference in boiling points here is a difference of 3,600 degrees Celsius and 1,090 degrees Celsius. Now, that's a big difference. So we want to take a look at why that difference exists. Now, what happens during boiling is a liquid converts into a gas. Now, when a substance boils, the atoms, ions, or molecules that make it up become gaseous, and they interact much less than they did in the liquid state. So if they interact much less, that must mean they're farther apart. So we're pulling the molecules, ions, or atoms away from each other. Now, to break these bonds that are holding the atoms, ions, or molecules together to become a gas, it requires energy. It takes energy for this to happen. Now, the form of energy we use here to convert a liquid into a gas is energy in the form of heat. That's why we're boiling magnesium oxide, or that's why we're boiling magnesium, because it takes energy. Now, ionic compounds have high bond energies, and magnesium oxide happens to be an ionic compound because magnesium oxide is an ionic compound of magnesium and oxygen. So it's an ionic compound. And ionic compounds have extremely high bond energies, which a bond energy is basically a measure of how much energy it takes to break a bond. It's pretty self-explanatory. So a high bond energy means it takes a lot of energy or a lot of heat to break that bond apart. And the ionic bond between magnesium ions and oxygen ions is very strong. So here you're having to break apart ions, and that break apart the ions of an ionic compound. So that's why the boiling point for magnesium oxide is so much higher than the boiling point for just plain magnesium.